In this video, I'm going to talk about the Clausius-Clapeyron equation. The Clausius-Clapeyron equation can be written in many forms, but the most common used one is its point-slope form, which is the one that I have in the screen. This equation has many factors involving vapor pressure. And well, the first one is the enthalpy of vaporization that we have right here. So delta H of vap or vaporization is enthalpy of vaporization, and this is usually given to you. And well, it's basically the energy required to vaporize 1 mole of liquid, and it's usually given in kilojoules per mole. The next factor is R, which is a constant, and in this case it is 8.314 joules per mole times Kelvin, which means that our third factor, temperature, has to be given in Kelvin. So if you get it in Celsius, you will have to convert it into Kelvin. And finally, the last factor is pressure, as in P, and the unit doesn't really matter because as long as they're the same for P2 and P1, they should cancel each other out. So it could be in torr or in atmosphere, whichever works, or any other unit you get, as long as P1 has to be equal to P2. That is the unit, not the value, of course. So now that we know all factors, our equation is the natural logarithm of P2 over P1 is equal to the negative, so be careful about that negative, enthalpy of vaporization over our constant R times the subtraction of 1 over T2 minus 1 over T1. And well, as you can imagine, the hardest thing about this equation is just rearranging for the variables. So now I'll solve a problem. We have, as you can see, most of the factors. We have the enthalpy of vaporization, pressure 1, temperature 1, and the question is what is the second temperature if our second pressure is 760 torr. So basically what you have to do is just rearrange the equation for T2 and plug in all the values. As I said, the hardest thing about the equation is just rearranging it. However, don't forget that you first have to check your units. So let's start with the pressure. We have in pressure 1 130 torr, pressure 2 760 torr. For the case of temperature 1, we have it as 34 degrees Celsius, and we need to change that into Kelvin. So we have 273.15, and then we get 307.15 Kelvin. And then the other factor we have is enthalpy of vaporization, 56 kilojoules per mole. We have to make that into joules per mole. So we then multiply by 1,000, and we get 56,000 kilojoules, actually joules, per mole. We convert it from kilojoules into joules. And now we can plug into the equation. So let's rearrange our equation. So here's the equation, and we want T2, so we have to rearrange for that. The first thing you want to do is multiply times R and divide times delta H of vaporization, the enthalpy. So you'll get the natural logarithm of P2 over P1 times R over enthalpy of vaporization is equal to negative, so you have to change this signs because of this negative here. So you can just invert it. It will be 1 over t1 minus 1 over t2. So after that, you can pass the 1 over t1 to the other side of the equation. You would have ln p2 over p1 times r the h minus 1 over t1 is equal to 1 over t2 negative. And finally, you have to pass this t2 into the other side, which means this has to go back to the other side and divide. So you can just write it in a simple way as t2 is equal to brackets r negative r times the enthalpy of vaporization times the natural logarithm of p2 over p1 plus 1 over t1 to the negative 1, which means it's 1 over all of that. And finally, it's just plugging in the values. So here are all the plugged in values. And to make sure that the equation was arranged properly, the easiest way is just to cancel them. And if they do, you should end up with Kelvin at the end here. So we'll see. Here we have joules over moles. Here we have joules over moles. Those cancel each other. We remain with Kelvin right here. This two should cancel out because they're dividing. And finally we have Kelvin here, which should be inverted because of the equation, as well as this one here. So they will add up because this one is in the denominator, if you couldn't see properly. And finally, because of the negative 1, they will invert into the numerator as a result. So after plugging in all the values and solving it, you should get 334.04 Kelvin. And well, that's it for this video. As you can see, the hardest part is just rearranging the equation. Thank you for watching this video. I hope you liked it and found it useful. And if you did, please be sure to give it a like and subscribe for more videos.